right. Hello, everybody. So I'm Dillon Kearns. I'm an Elm trainer and coach at Incremental Elm Consulting. And today I'm going to be talking about Incremental, TDD, and Elm. Now, I'm not going to be talking about test-driven development in Elm, though I highly recommend you try it if you haven't already. It's a great practice. I'm going to be talking about a complementary technique, type-driven development in Elm. And now the difference between what I'm calling type-driven development in Elm and test-driven development is with type-driven development, rather than getting our feedback from a failing unit test, we're getting our feedback from a compiler error. So we're going to be using the techniques and principles of test-driven development with our Elm coding, using the Elm compiler to drive our feedback. So test-driven development has this core concept of the red-green refactor cycle. That's what we're going to be doing here. So when you go through the red cycle, you make a wish. You write code as if you had it, even though you don't. And then you try to make that wish come true, but you do it the quickest, dirtiest, simplest way you possibly can. So you fake it till you make it, you hard code, you use all the dirty tricks you have at your disposal to just make that thing pass. In this case, to get the compiler passing again. And then you go through and you remove that hard coding once you've gotten it to a green state as quickly as possible. And along the way, it's often very helpful to make lots of tiny refactorings. So make the change easy so that you can then make the easy change. So we'll be using that technique a lot. Okay, so here we go. We're going to be live coding. And so here's an app I've got. It's just a little app that shows you a few different countries in an itinerary. So what we want to do here is we want to have a URL that we can share with some friends so they can plan out their trip, see stats and information about various countries that they're going to visit. And you can just share the URL. All the country codes are stored in that URL. But as you can see, we're not showing stats and fun information about countries. What we're looking at is a list of country codes. And that's because we've got our view function here, our country view, which is just rendering the country code right now. So going through our red-green refactor cycle, let's start by making a wish. So what I really wish is I wish that in my country view I had access to some data that I could look up for each country. So I'm just going to write something as if it existed, even though it doesn't yet. I'm going to wish for having a list of countries available here, or some sort of data type. And of course, the Elm compiler tells me it can't find a countries type, so let's define one. Now, I could take a guess at what that type is, but I want to drive all of these things with feedback from the compiler telling me you need to do this. Right now, there's nothing telling me that, so I want to fake it till I make it. I want to do the simplest thing that could possibly work. So now the Elm compiler is telling me, well, you're not passing any of that data in to your country view. So let's pass it in. But what I really want to be doing here is I've got some JSON data that I'm passing in through a flag from an NPM library. It's got a bunch of data about different countries. So I'm going to need to grab that data from the flags in my init function. So really, I want to wire that through. I want to integrate rapidly and early and often so that I can get feedback and validate what I'm doing along the way. So what I really wish I had here is instead of just passing that data type, I wish that I could just grab it off of the model. So let's pretend I can. Let the Elm compiler tell us something's wrong. Of course, it's not in our model. Let's put it there. And the Elm compiler tells us, in order to satisfy the compiler, we're going to need to initialize that data in init. And there we go. So we've wired it through there. We're not really doing anything interesting. So what we want to do is we want to start using it the way we want to in our view. So what I'd really like to do is I'd like to look up a country. So let's just write that. This is a great thinking tool. It helps you kind of think at a high level before you get stuck in the weeds with the low-level details of your coding. So I'd really like to look up the country code with a list of countries. And then in the case that I find the country, I just want to display some data about it. And in the case that I don't find the country, we just want to say that it wasn't found. And of course, the Elm compiler tells us this function you wished for didn't exist, so let's make that wish come true. So it takes a string, the country code, list of countries, and it gives back maybe a country. And notice that I'm using the Elm Jitsu plugin, which just popped in the default value of nothing, because it can say, hey, I'll hard code a value for you. So Elm Jitsu actually has a nice little tool there for you to fake it till you make it by putting in the simplest value that you could hard code. Okay, so now Elm is saying it doesn't know what country is. So let's define it the simplest way we can. Now in this case, I know I want to be grabbing some data off of it, so I'm just going to define it as an empty record. Okay, so now we're getting some feedback from the view, but we're not actually looking up any data. So what we want to do is we want to verify that our design is actually able to solve the problem. Can we actually look up data? So we want to integrate and validate these things as quickly as possible as a way of getting feedback, so we're not going in an incorrect direction for a long time without getting feedback that something is wrong. So what I want to do here, so first what I want to do is I want to actually look up data the way I'd want to. So how do I, given a country code and countries, how do I look up that data? Well, really it would be nice if I could just, if I want to look up a key in a key value store, let's just say I want to do a dictionary lookup. So I want to look up that country code in the countries. And then the Elm compiler says, well, you're using countries as if it were a dict with a string key. So let's change our countries definition to a dict with a string key. And it gives us back a value of type country. And now the Elm compiler is telling us you're initializing it to the wrong type. We'll initialize it to the simplest dictionary we can. So now I want to add some hard-coded data so we can actually validate if I had this end-to-end integration, is it actually able to look up countries? So I'm just going to give this a name. I'm going to call this empty dictionary init countries. I'm going to give it a type annotation and use our type alias. And now I want to hard code some data, but it's a little inconvenient with this empty dictionary, so I'm just going to do a little step to make my next step easier. So I'm going to make the change easy so I can make an easy change. So I'm just going to rewrite an empty dict as dict from list with an empty list. Now it's easy for me to just add this key value pair. We have our empty country record, and we're successfully looking up data in our dictionary. So we've validated as quickly as possible that we're able to actually look up data in our data structure. But now what we want to be doing is we want to validate that the data that we're parsing in our JSON decoder is actually able to be parsed into that data structure. So we have sort of a specification that, yeah, if your data were in this format, you'd be able to do what you need to do. But can we get the data into this format? So now we have a new target, a new goal. So what we want to do is, well, first of all, I wish that I had access to my flags here, so I could decode some JSON data in those flags. Let's let the Elm compiler tell us we need to pass flags in. And now what I want to do is I want to do some sort of decoding. So I need to decode a value. I need to pass in a JSON decoder. Let's just call it decode countries. And my value is just flags country data. And it doesn't know what decode countries is. Well, it's a decoder of countries. And in particular, I'm just using the exact same hard-coded data that we had. So again, this is a pure refactoring step. I'm not changing behavior. I'm only changing the structure of the code because I want to take tiny steps and get feedback from the compiler and have it support me along the way instead of pulling out all the pieces and then fitting them together all at once. So I can make this hard-coded value into a JSON decoder if I just do JSON.decode.succeed with this value. But now I'm getting a new error. It's telling me that it's actually getting a result back here. Now what I want to do, since I'm doing this with the test-driven development sort of philosophy, I want to follow one path all the way through as quickly as possible to get an end-to-end slice working. So I don't want to worry about this edge case right now. I will come back to it later in my development, but right now I just want to get an end-to-end thing working. So I just want to get past this by saying result with default with an empty dictionary. Okay, so the behavior is exactly the same. These are all refactorings, and the entire purpose of these refactorings is I'm trying to take this hard-coded string, the country code, the key for my dictionary, and I'm trying to remove the hard coding there. So I want to see it able to look up this other country code. But I can't just remove the hard coding in its current state. So I need to massage it a little bit to do that. So again, I'm going to do some pure non-behavior changing refactorings. I'm going to make the change easy so that I can then make the easy change to remove that hard coding. So here's a change that'll get me one step closer. I've got dict from list. Now let's take that dict from list. So instead of decode.succeed with just a hard-coded dictionary, let's decode.succeed with a hard-coded list of key value pairs. That's incorrect. But now I can just decode.map dict from list. Just a simple behavior change. No behavior has changed, just simple refactoring. Let's follow a similar process. So instead of a hard-coded list, let's have a decoder that gives us a hard-coded key value pair, and let's decode a list of those. Behavior hasn't changed, but we're getting closer. So now, if I want to actually decode data into a tuple, I'm going to need to take two decoders and map those two decoders into a tuple data structure. So I can do that with tuple.pair. And then I need the two decoders for the left side and the right side of the tuple. So let's have a hard-coded decoder for the left side, a hard-coded decoder for the right side. No behavior has changed. But I made the change easy. Now I'm teed up to make the easy change. I can remove the hard coding here now. I've unlocked this piece that I can now remove the hard coding in. And now we're finally looking up the data in the JSON. We validated the JSON data is actually parsable. We can get it into this data format. Okay, so now I'm going to make another wish. And I'm not going to just start decoding more data in my JSON. I want to drive it from actual usage. So I want to sort of create that red state instead of just decoding a new thing. I'm going to drive it from the way I'm using it, which is the view. So we're showing the country codes, but what I really want to see is the country name. So I wish that I could just say country.name here. That would be nice. Let's make that wish. And let's use the Elm compiler to help us make that wish come true. So it's saying our country data structure, our country record, doesn't have any fields at all. But we're saying that it has a name field. So let's change our data type. Let the Elm compiler tell us where we need to fix it. And what do? Do we create a new decoder? No, we fake it till we make it. We want to get this green using all the dirty tricks we have up our sleeve so we can take the quickest path to getting it green. So let's just hard code in data to the country. There we go, hard coded data. Okay, but we need to remove the hard coding. So what do? We make the change easy so that we can make an easy change to remove the hard coding. Right now, I can't really remove hard coding in this data. But if I had a decoder that gave me a hard-coded string France, and then I just mapped that data into a country record, now I'm working with something that I can actually remove the hard coding in easily. So now I made the change easy. Now I can make the easy change. All I have to do is decode this field. And I expect it to be a string again. There we go. So now I'd like to see the population for these countries. But what I'm going to do this time is I'm just going to hard code exactly what I'd like to see, almost like mocking it up like a design sketch or something. So I'd really like to see population like this. Now, again, I'm stuck with this hard coding that's locked in. So I want to unlock that hard coding through some refactoring steps. So let's do that. Let's rewrite this string in some ways that unlock the refactoring, that unlock the hard coding. So surround it with parentheses, nothing's changed. I'm going to split up the string into two pieces, nothing's changed, behavior is exactly the same. I'm going to express this string as string.fromInt, exactly the same. And while I'm here, I've got a handy dandy little function that will format this integer in human-readable terms, showing the millions instead of a bunch of numbers. So now I've unlocked this hard coding. So now I can make a wish and have the Elm compiler help me make that wish come true. So I wish that I could actually just grab population off of the country that I looked up. Well, the country record doesn't have a population field. Let's change that in the type definition and have the Elm compiler tell us what we need to change to make that true. Now in this case, I could hard code this value, and that works. Often in this situation, all of these techniques are things that are at your disposal. It's a toolkit that you can grab when it serves you. So I could reach for this toolkit of hard coding it to get it to take the fastest path to getting it green, to getting it compiling. But in this case, it's such a small step, you don't need to be dogmatic. It's kind of like having different gears in your car. When you want to go up a steep hill, it's nice to be able to switch back into first gear so you have more power. But in this case, since this is such a small step, I'm not going to get stuck along the way, so I don't need help of breaking it into tinier pieces. So often I would write this as just creating a new field decoder straight away. In this case, it's decoding into an int. Now we've got populations. And then lastly, it would be really nice, let's make one more wish, if we had images for those countries' flags. So we'd have some sort of source that would be a string, and ideally I would grab a real image that's on the country data. So the country record doesn't know about flag image. Change the type definition, have the Elm compiler tell us what we need to change. Again, I'm going to skip the hard coding step here because it doesn't really help me go faster in this situation. Decode the string. Now we've got our flags. And finally, I can add US to the list. Now we've got a list of all the host countries for Elm countries, for Elm conferences. So I can grab this link, send it to my friend, and help them prepare for their tour of Elm conferences around the world. So again, we were just using the techniques from RedGreen Refactor test-driven development principles in order to get feedback from our Elm compiler and have it drive what we write and help us write code more easily. So we start with a wish, we fake it till we make it and hard code things using all the dirty tricks up our sleeve. We remove the hard coding, and as needed, we make the change easy so we can then make easy changes. So I write about a lot of things like these fun techniques for how to approach writing Elm code and how to kind of organize Elm modules and things like this. If you find that interesting, check out my tips. I send out weekly tips just like this one every week, incrementalelm.com/tips. And that's all. Thank you so much.